My name is Nicole and I work on malaria. Malaria is a devastating disease caused by parasites and transmitted by mosquitoes. Malaria causes over 400,000 deaths annually, and these are usually children under the age of 5 in sub-Saharan Africa. Despite progress over the past decade towards malaria eradication, progress has stalled and new approaches to eradication are needed. One of these approaches are called transmission-blocking vaccines, which work by preventing the development of the parasite within the mosquito vector, which therefore blocks transmission of the parasite. So if we immunize someone who has the parasite, when the mosquito bites them, they take up the parasite, but they also take up these antibodies, which are able to block the development in the mosquito and prevent the transmission of the parasite to another person. So our transmission blocking vaccine focuses on a protein found in the mosquito midgut, and it's called AnAPN1. When antibodies bind to this protein, they block one of the parasite stages, called an ookinete, from passing through the midgut of the mosquito. If it's able to pass through, it will go on to develop the infective stages of the parasite. So by solving the crystal structure of AnAPN1, two important transmission-blocking epitopes, peptide 7 and 9, and a decoy epitope, peptide 1, were identified. We found through immunizing mice that peptide 1 was a decoy epitope, which generated really high responses in mice, but these antibodies that were generated didn't block transmission of the parasite. So we decided we didn't really want that in our vaccine candidate. We also saw that antibodies that were specific to peptides 7 and 9 blocked transmission really well. So we decided we wanted to try to focus the immune system to these key peptides. So to do so, we generated UF6, which is a dimer construct of peptides 2 through 9, and it's connected by a linker. So to test this new AnAPN1 construct, we immunized mice either with UF6 by itself or in conjunction with an adjuvant. And adjuvants are just used to increase the immune response. So we analyzed serum collected from the mice through ELISAs, which are used to determine the size and strength of the immune response generated, and through standard membrane feeding assays, or SMFAs, which are used to determine the transmission blocking capabilities of the antibodies generated. We found that even by itself, UF6 was able to generate a high antibody response in mice, and when injected in conjunction with an adjuvant, the response was even higher. We also found that antibody response was specific to peptide 9, one of the key peptides, but it didn't recognize peptide 7, and we also found that they no longer recognized peptide 1, which was the decoy epitope. We also found that these antibodies that were generated were able to reduce parasite transmission in the mosquito by 84 to 95%. So these results are very promising, and we will continue to test and evaluate this new construct as we hopefully move towards clinical trials. Thank you.